Okay, everybody, this is Paul N0B for the Front Range 6-meter group. And tonight we have Paul N2EME going to talk about SDRs and SDR console and some of the neat tools that he has to help you guys if you ever want to start using SDRs. So with that, I'm going to throw it over to Paul. And Paul, can you pick it up and can you share your screen?
Absolutely. I'll do a screen share. It should be this one here.
Yeah.
And we should go to the large one. There we go. Okay, we should be looking at the large screen there, yes?
Yep.
Okay, yeah, thank you. Looking at all the names on here, we can probably get this over in about 5 minutes because most of you know more than what I'm going to be talking about. You've all seen this picture before, which is one of my favorite ones of 6 meters during the opening on an SDR, where you can see most of the different modes, CW, SSB, digital modes, etc., all at once. You can also see here where my heating system turned on and off. I know exactly what that line is for. So that's one of my favorite pictures. I have a slightly better one further on, but I'll use it as a hold. Again, most of you know who I am, Paul N2EME, located near Boston, and a member of N4EME, KA1EME. And I've been playing with SDRs for over 10 years now. And again, looking at the faces here, most of you know even more than I do about them, because I know a lot of you use SDRs. Any of the SDR pictures, I've tried to use a $35 new electronic one just because it's cheap. So those of you who don't know about SDRs and want to get in can see what you can do with one. To tell you how good this awful piece of cheap, used to be $25 SDR is, Lance, I know, has done EME using one of them. So that is how good an awful crappy receiver cheap can be. A lot of you know me from N4EME with K10R sat here. He did all the operating. I'm not allowed to operate because I'm not very good at it. So I get an orange highlighter, and that's as close as I get allowed to be in operating. But that's up in FN66 and FN57. So that's what our portable station looks like. Okay. Normally, there's a lot of newbies on that don't know anything about SDR, and I'll say that most of them aren't going to believe anything that I say here. And I've got used to it, and I don't really care. And as one of the most of you guys remember the guys who tried to operate from Newfoundland to work in Europe on 2 meters a few years back. Sky was one of them, V1SKY, and he was the only VHF operator in the group and the only one who had an idea of how VHF worked. And I offered them an SDR to use and set it all up with the software, and so they could record to a hard drive and record the whole week's reception. And they said, no, it can't be any good. It's small and cheap. Our IC706 is better. And that was actually a FunCube, which is FunCube Pro Plus, which is still one of the better 2-meter SDRs out there. And many of you are going to feel the same way. How can a little tiny SDR be any good? It's a small, my rig's expensive. So don't care, end of story. Just a couple of different SDRs. This is the $35 one. And again, there's something special about this one. It outperforms anything it should perform. It shouldn't do as well as it does. FunCube Pro Plus, you can see if any of you guys are buying these used, just there's a blue plus sign in the middle of the Pro. That's how you tell the one you want. The other one is exactly the same without that blue plus sign. This is one of my N2EMEs. I think I've got 3 or 4 of these. They're 0 to 60 megahertz transceivers for SDR. And you see this one says 2 and 222 because this particular one drives the transverters. This is a Lime SDR which is also transmit and receive. They're about $300 and they cover 25 megahertz all the way up to 3.1 gigahertz. You can buy an expansion board for them to take them up to 10 gigahertz, but this one doesn't have the expansion board in. So remember, your computer is your radio. Forget reaching down to turn knobs or anything like that. Your computer is going to become your radio. As radio hams, we're always looking for the best receiver. Transmitters are easy to do. Getting power out is easy. But if you want to improve your grid score, etc. in contest, you need to upgrade your receiver to have the best receiver to make the best use of the receiver. None of the big three radio producers are even close to the SDR that's out there, for $50, $100, $150. And a lot of that is because they keep their radios talking to their own proprietary software. So you can't use the good software. And I can tell you, it is all about the software. Most SDRs can only receive, but there are ones that are transceivers as well. For this conversation, I'm only going to look at the receivers. I'm not going to bother looking at transceivers, but we're going to talk a little bit more about that as we go along. Your eyes are your radio as well. With an SDR, you're going to be able to see signals before you can hear them, which is great for those guys who like contesting and you turn your antenna. If you watch your waterfall, you'll see like a green hue come up on your waterfall, and that'll be an SSB station long before you can hear him. And I hate CW. I detest CW. I just have no interest whatsoever in CW. And I can tell you, I am so impressed with SDR console and an SDR on CW. The way you can set a filter to 50 hertz on a 20-meter contest and pick out one station when everybody else is there. Normally, you'd be happy with a 600 hertz filter and trying to pick a station out of everybody in there. With SDR console, you can go down to 50 hertz and just pick the width of one CW station. Most of you know the story. A friend of mine was trying to work K4N when they were on some island somewhere. And he couldn't hear them on his ICOM and he couldn't hear them on his FunCube. But he actually worked them by decoding their CW signal going down the waterfall. He could read the dots and dashes of the station going down the waterfall, even though they weren't strong enough for him to actually listen to on the speaker. So again, I hate CW, but boy, is it good with SDR. Okay, general rate receiver or band specific. No brick radio can do from DC to 10 gigahertz. No SDR can do from DC to 10 gigahertz. Some might try, but none do it well. So just like with your normal brick radio, your normal ICOM, Kenwood, whatever, you choose the right radio for the right band. So we've got HF, 6 meters, 2 meters and up. $35 starter from New Electronics covers 25 megahertz. Yeah, it really covers some 50 megs, guys. It doesn't really do 25 megahertz very well. Up to 1750. This is good. It is very stable. If you find a nice stable signal, you can watch it on the waterfall. There's very, very little drift in it. It performs way above its price. It's a great way to learn. As I say, I'm flipping through all this lot really quickly because most of you have heard me say this about all these before. AirSpy HF Plus Discovery, $169 when I looked last week when I put these slides together. Covers bottom end all the way up to 31. Covers from 60 to 260. It does not cover 6 meters because of the way it works with a converter to get up to the 60 to 260 megs. It does HF very well. It's probably the best HF receiver I have ever played with. It's very poor on VHF. and it's to do with the way it's not direct receive. It's the way it's used as a converter. Don't look at this if you want something for VHF, but if you want the best HF receiver you've ever played with, then this may well very well be it. For those of you who want 6 meters and 2 meters and up, the S/R2. I know Paul has some of these. I know Lance uses these for his current station. In fact, I read earlier on that Lance transmits on his K3 and receives on one of these R2s. And we all know K3s were a nice radio. $169 when I checked again this week. If I'm talking to you with 6 meters and VHF guys, this is the one to buy. Again, we're back to a slightly better picture. This one shows on the R20, the little $35 SDR. This was 6 meters, and it just purely happened to be the band was open. You can see a lot of CW down the bottom here. SSB isn't dead. Look at that. There's 1, 2, 3, 4, 5, probably 10 stations there. And then all of these digital stations up here. And the way this is set up, and we've discussed this on a previous video, so if anybody's interested in this, the Front Range group do have a previous video on YouTube about this. This is set up so that I am decoding and receiving all of these at once. So for those of you into 6 meters, imagine being able to see the whole of 6 meters at once and decode it all at once. So these go to a speaker. These go to individual versions of WS instances of WSJT. You're not just looking at 3 kilohertz, you're looking at the entire VHF band. Connecting it all together, your radio with your SDR. You can look around for different software and play with different software, or as Lance put it a few minutes ago, that most of you don't have very long left. So don't even bother. Just go straight to SDR console. Don't waste your time trying to find something better. You're not going to. This is by Simon Brown, who we all know from Ham Radio Deluxe. It's donationware. If you like it, send him a bit of money. And you'll find that it's probably the best piece of software that you'll ever play with. Now you have to connect your radio, your SDR receiver, to SDR console. You do that using virtual audio cables. Think of these as being 2 cables with 3.5 millimeter jack plugs on either end that you plug, one into the SDR, one into your computer, except it does it all inside the computer because we're talking digital. These I recommend from a guy with a Russian name who lives in Canada. And when you start Googling, it'll be pretty obvious who he is, because it'll be the name that you can't pronounce. Now, to control things, you see I've got WSJT here. You want to be able to control things so that SDR console talks to WSJT to move frequencies. The software for doing that is OmniRig. Free software, you download it. There's a link in SDR console for doing so. So what that does, it connects your radio to your SDR, which OmniRig is down here. And they say you can go back and look at these settings from Paul's video. This will give you a rough idea how to set things up. Virtual audio cable, I've got 10 cables set up on this particular one. So think of that as 10 individual receivers for up here. And these are also used for transmit, as is all of this. All of this can be used for transmit. And then obviously you're connecting it to WSJT, or in this case, JTDX, because it fitted it nicely in that corner of the slide. Okay, but I want to transmit. So you've got a great receiver. Everybody's got a good enough radio. How do I transmit? Well, various ones we're going to go through. I just want to say that what you can't see here, and it was deliberately done in the photograph of this, because in case things screwed up and didn't work, Bill didn't want his name on any of this. So those of you who buy it, just below it says RV1, it says designed by ND0 Bravo. And, but he deliberately wanted the picture so it had nothing to do with him and he didn't have to live in Hawaii all his life. So this is an SDR switch, and I've got more information in the next slides about different ones. And most of you know I've been selling, I think I've sold over 200 of the original design SDR switches, and they were never good on 2 meters. So Bill sat down and he designed a range of SDR switch products that do 2 meters and above. I mean, 450. You can even get away with one, you know, a lot higher than that. But 450 is where I'm putting my name on them. You can see good relays and, unfortunately, ka-ching, high price relays, which will come in when we start looking further down these slides. You'll understand why I'm pointing that out. Now, if you want to do transceiving, and we're not talking about a flex, we're talking about using your brick radio for transmitting and an SDR for receiving. That is going to give most of you the best station you can ever dream of. If you've got one of the icons, the 7300 or the 9700, there's a couple of firms make exactly the same product and they both say it's their product and the other person stole it off them. I don't care. PTRX 7300 and PTRX 9700, funny enough, they both have the same name, fit the 7300s and the 9700 icon range. They're also coming out with one for the 705. If you have any of these radios, that would be one of the best ways to go, as long as you're happy enough opening your radio up. Next page, there'll be a bit of a description of that. MFJ do a 1708B, which is their SDR switch. And Marv is going to do a little bit of a talk about that one, as he's done some independent measurements on it to get my name off it. Very high insertion loss. And he'll explain why that matters shortly for you. Mini kits. This one's a little bit sad, unfortunately, because mini kits, and it says EME 222, that's not me, but you can assume that they're going for EME on this. And it's good to 150 megahertz plus. Great. Mini kits out of Australia make wonderful products. I don't quite understand why they have this one in their range. On 2 meters, it's got a 3.7 dB insertion loss. So take half of your antennas down. Oh, I can see somebody grimacing. Wait till we get to the MFJ one. That 3.7 is going to sound wonderful. Yeah, so take half of your antennas down. For those of you who are sat Googling SDRswitch.com, I'll save you the time. I haven't put the website together. I'll do that this winter in France when I'm not sat in the snow. But I figured I'll put it on here because I know these videos get played back because Paul records them. So SDRswitch.com is the ones designed by Bill, and they are designed with weak signals in mind. And I'll talk about them as we go through. And I will say at this point, before we even get there, I make no apologies about the price. They are not there are not $139 MFJ ones with massive insertion losses, but you'll understand that as we go through. The other way of doing it is you can do it with just a sequencer and an RF relay. You pick up an RF relay for about $60 and a sequencer for about $30 and make your own. It's easy. It's very easy. Okay, PTRX, again, for the 73, the 97, and the 705. These are little boards that go inside your radio. So you take the radio apart, you disconnect the lines going from the receive, and you put this board in and then reconnect the lines. If you've got these radios, I can't think of a better way of doing it. I have both of these products in my radios. If you've got grandkids, they might be far better at putting these connectors on. than you or I are ever going to be. These are very, very small. They are very easy to break. If you decide to go this route and you're not confident, get a friend that's not got Parkinson's disease to actually connect these up for you. Because once you start wobbling and get them off, I've broken them before and had to replace them on a board. The way this, go ahead.
Yeah. So the output of this is RF that goes into your SDR.
The output of this will be RF, yes. All this is a way, if we go down to this picture here, you can see this is for the 9700, VHF in, UHF in, 1.2 in. So it's an in and out, it's a loop, and it comes down, they all mix together. There's an amplifier to take care of some of the loss, because obviously when you split a signal like this, you're going to have some loss. They put an amplifier in, that gives you RF out. On 2 meters, you're going to receive directly on 2 meters. On 432, you're going to receive directly on 432. The odd one out on this one is on 1296, you're going to be receiving around 366 megahertz, because the 9700 has got a transverter in it, basically, for now. And so you're listening to the IF of the transverter, easiest way to describe it. But if you've any of these radios, and you're comfortable going inside, I highly recommend these. You just put onto the back of these the SDR of your choice. Okay. So we all know our rig's good enough. This is a IC706 that was photogenic. It fitted in the picture. So that's why it got used. This is a SDR switch, 0 to 70 megahertz. You can see it's got different relays in. You have your antenna coming in. You have your transmitter connected to the TX, and you have your SDR connected to the RX. This particular one on the back, you've got power in, you've got PTT in, and you've got PTT out, which goes to your amplifier or any other gear that you want to switch. This is the same on most of the other ones I'm going to show you very shortly. I just happened to put this one here because I can explain it easy off the picture. So here are 3 of the main ones. The MFJ, which we've all seen, not quite sure what they were smoking when they did this. You have to put your fingers inside it to put an SMA connector on. And obviously you've got the transceiver and the antenna. So just like on the SDR switch that you saw by myself here, it comes in, the signal comes in, it comes out to the transceiver or on transmit, or it comes out to the receiver on receive. When you go into transmit, this SDR receiver is taken out of line, just the same as these relays here do. And your transmit signal goes in and comes out. This and the mini kits one, which works on the same idea, both of them, as you're going to see when Marv starts talking, have got some very bad losses, because what happens is the signal is split inside both of these, so that when you're in receive mode, it comes out of here and here. So imagine putting a splitter in, you've immediately got a loss. On this particular one here, when Bill designed it, it was designed to have minimum losses possible. You guys are all VHF guys. You know, why do you want to put up a 7-element Yagi on 6 meters and then cut it down and make it a 4-element Yagi? You want to keep every dB possible. So 2 basic designs. One of them, it comes out of the transmitter and receiver at the same time, to the radio and to the SDR at the same time. On this one, it does not. I will talk about one a little bit further on that does, but for the moment, just think of it at the moment, we're just going to discuss it as that's one of the problems between the differences between the two. Now, Marv is going to take over from me for now. I'll hit mute, and he'll tell me when to change screens. Go ahead, Marv.
Okay. Yeah, okay, Paul, you can go to the next screen. So I purchased one of Paul's switches, but prior to that, I had the MFJ one. So just to start out the talk is like, why do people even, use an SDR and an SDR switch? So one of the reasons that I started using it was for the band scope capability. As Paul said earlier, you can see the whole band at one time. You can find an open frequency, on sideband, CW, whatever you want, whatever mode you're in. You can also identify weak signals that you can actually see. So like he said, you get to use your eyes as a receiver. Another reason is the SDRs often, as Paul pointed out, have better performance than your brick radio. They certainly have more buttons and knobs and switches and things that you can do in terms of noise filtering capability. So if you've got a severe noise problem, chances are you can find an SDR receiver and play around with the filtering to get rid of it. Another reason why you might want to use that combination of an SDR and an SDR switch is that you can monitor a different band. If you've got a multi-band antenna, or you hook things up certain ways, you can be on one band and monitor an entire other band. I usually do that during contests when I have a second radio or something. So now instead of spinning the dial to see if the band is open, all I have to do is look at the SDR. If I see a lot of signals, the band's open, I change bands and I keep going. Okay, so you can monitor one band while operating another. And you've got to use a switch, as Paul pointed out, because you've got to switch that receiver out when you transmit. Okay, next slide. Okay, so we talked about a switch. What's really important in these SDR switches? What specs are important? Well, first of all, number one thing is isolation when you're transmitting. You don't want to blow up this SDR receiver, even though it's cheap. You still don't want to blow it up every time you transmit. So one of the key specs is your isolation during transmit, right? You're not overloading that receiver when you're actually transmitting. The other key spec is, I think is probably the most important one, is the insertion loss when you're receiving. As Paul said, if you put up a 7 or 8 element array to give you 10, 12 dB a gain, you don't want to lose half of that gain, particularly with weak signal work. In these frequencies we talk about, we put up multi-element beams, use very low loss coax, right? So doing everything we can to get every microvolt of that signal to the receiver. Then you stick, so the insertion loss of anything you put in that path, you want to minimize. And you also don't want to impact the noise figure. So the other reason why you need the switch is obviously the MFJ one has the capability to do RF sensing, to do automatic TR switching, or you can use the push to talk line. And with the MFJ one, you can use either one. And with Paul's switch, it's just using the PTT line, which I think is a much better way to go. It's safer. You're relying on some circuitry and the RF sensing to kick in time to switch out and again prevent you from blowing up that SDR. If you've got the PTT relay switch, it's out of the circuit when you transmit. Okay. Now, these switches are used in their spec both for the HF bands and also for UHF and VHF. On the HF band, what's really important is you have that isolation during transmit, between the transmit and receive, because usually in the HF band, you're running power, 1 kilowatt, 2 kilowatts, 500 watts, something like that. I know a lot of you guys run power in UHF, VHF, but for the most people don't run a lot of power unless you're doing EME and some other things. But so in HF, I think the most important spec is the isolation. The UHF and VHF, though, it's the other way around. The most important spec is the insertion loss, because everybody's not running power or you're getting signals off the moon or whatever. It's more of a weak signal type of operation. So you need every dB to get to that receiver. Okay, and stop me if there's any questions. So here's what I did. I took out my VNA. I took the MFJ switch, and the MFJ this is revision B, the 708B. They came out with the 708. Then the 708B, where they went back and improved the performance of it above 30 megahertz because it was so bad. Even though they improved it, it's still not so good. So what you see on the left is the Smith chart, if you guys are into that. And on the right, you've got the SWR and the insertion loss you see in that table measured at each one of those bands. So you can see you're losing 2.4, 2.5 dB of loss. When I went to school and they taught RF theory, 3 dB is half your power. So you're almost losing half of your signal. And you can see when you get up to 2 meters and 70 centimeters, you're losing over half of your signal. And also the SWR isn't so fantastic. The MFJ switch has got a hybrid splitter in it that splits the incoming receive signal so that your brick receiver gets it and also the SDR. Well, if you're comparing the two, if you want to see how your brick receiver is doing compared to the SDR, maybe you don't mind it being split. But look at the sacrifice that you're taking in terms of insertion loss. So the question is it worth it? Okay. Next slide. I looked at Paul's switch, and needless to say, if you look at this one, you can see which one is now left in the line, at least in my station and working. Incredibly low insertion loss, all the way up to, I probably should have taken up to the 23 centimeters. I'll do that test later, maybe update the chart, but you can see at most 0.3 of a dB at 70 centimeters. The SWR stays nice and flat, okay? And that span on the right goes from 50 megahertz fixed 6 meters all the way up to 450. And the SWR is the bottom line. You can see that with the blue scale on the right, and that's right around 1 to 1. And on the left is the insertion loss. So you can see it's nothing. Okay, next. So what conclusions did I come to? Well, first I wanted to make sure that I was doing a reasonable test. So the MFJ 1708B was reviewed by ARRL in an issue of QST. I think it was March of 2019, but you'll see that on another slide. I put some quotes out of that. And like I said, they use this hybrid splitter that while you get simultaneous reception, it severely impacts your performance. The SWR goes through the roof at the UHF, VHF bands. So I wouldn't use it for weak signal work at all. Paul's switch, I think, is what I'm calling N2EME switch, is a better way to go. One of the things that the MFJ, you can see Paul used the tuned PCB track, to keep them all 50 ohms and nice and neatly matched and everything. MFJ, that was what they did with the B version. So it's better than it was with the A. They started using matched PCB tracks, but they still didn't do such a great job because they've got that hybrid splitter in it. Okay. And one of the reasons why Paul said his switches are more expensive and he makes no excuses for it is because the choice of relays used. MFJ uses very cheap and inexpensive relays. When you saw that picture before and Paul said, why do they do that? Make that giant hole to stick an SMA connector in there? Well, because they make two versions of that. One has an SO239 socket. The other one has an SMA socket. And they're too cheap to make two different cases for it. So they just put the SMA in the bottom of the big hole. Okay. One of the, if you want to call it a disadvantage from Paul switches, it doesn't allow you to simultaneously, receive the signal at both your transceiver and the SDR, and it also doesn't have RF sensing for automatic switching. Okay, not that important to me at all. Okay, next slide. Okay, yeah, you can go to the next one. This is, if you were curious of what the MFJ is on the HF bands, you can see it's not that bad. So this goes, we're going from 1 megahertz on the left all the way to 30 megahertz on the right. And you can see from the table at the bottom, the insertion loss, maxes out at 2 dB on 10 meters. Not so bad, right? The SWR stays below, 1.6, 1.71. Again, not so bad. So at HF, it's not such a bad thing in terms of that, but still there is some loss. So if you're worried about working the weak ones, and, I've been a ham for close to 50 years, and what the old hams used to tell me is if you can't hear them, you can't work them. So if you keep that in mind, you want low insertion loss. So that's what the MFJ one looks. And the next slide, I even took Paul's down to the HF bands, and guess what? It's even better. It's pretty much flat. At least with my VNA, I couldn't measure any insertion loss from 1 megahertz up to 30. I couldn't detect any SWR change, mismatch in terms of impedance. It was flat 1.01 to 1 across that entire spectrum. So even if you're going to use it, you can leave it in the line with your transceiver and use it on the HF bands, and it's not going to hurt you at all. Okay. Next, so this is QST March of 2019. If you want to go, if you get you're a league member, you go online, you can look this up. I pulled out. They did a review of the MFJ 1708B. This is the top half of this, the tables that came out of that review, where they said there was a jumper that the jumper that they're talking about, JP2, is whether or not you're using the RF sensing or not. So with the RF sensing enabled, things are a little bit worse than it is with it disabled. You can see they even measured 3.5 dB loss. So that's, again, over half your power on 6 meters, 5 dB at 2 meters, and almost 7 at 70 centimeters. Okay. And you can look at the isolation and the VSWR measurements on theirs. So I took this little quote out of the conclusions in the write-up where they said both switches, they were talking about the 1708 and the 1708B, use that hybrid splitter. And the reason for putting it in that was to provide more isolation between the transceiver and your SDR on receive. But again, the penalty, as they said, at HF, that results in a 3.5 dB insertion loss between the antenna jack and transceiver, or SDR jack and receive. And they said that's hardly noticeable on the air. Now, whether they did that because MFJ is a big advertiser in QST or something, I don't know. But I think I would notice. Okay, losing half my signal strength and receive, I think I would notice it. I think they're saying it's hardly noticeable in terms of its impact on your transmit path, but if you're talking about weak signal, I believe it is noticeable. So I think that was the last one, was it not, Paul?
It was, and thank you, Marv. And
Okay.
For those of you, I don't actually know Marv before he bought the switches off me. He wasn't one of the guys I normally chat to or anything. He just asked if he could put something together because we discussed that I had this talk coming up for Paul, and he asked, do you mind if I put something together, because I want to show an independent view, because I'm biased. I like the ones that Bill designed, but he wanted to put something in there that was independent of me. And just, these are my figures that I measured on this is the SDR switch that does 0 to 70 megahertz. So this is a cheap one. It's not using the very expensive relays. And for those of you with eyesight as good as mine, on 50 megahertz, the insertion loss is 0.042 dB. Again, 0.042 dB. On 2 meters, which it was not designed to do, it was designed only up to 70 megahertz has been its design, its build specification. The insertion loss is 0.117. Again, 0.117 compared with what was the MFJ 5 dB. But again, that's not the good one that was aimed at 2 meters. It just happens to do it. And the reason we brought this one out was to keep a price point. Now, the one that does 0 to 450 megahertz plus, you'll have a little difficulty seeing these, I think. But the 6 meter, the insertion loss is 0.020. Again, 0.020. On 144, the insertion loss is 0.071. And on 432, where I think they were up to 7 dB, weren't they? We're at 0.568 dB. So if any of you guys are thinking, work out what's worth the most to you as far as whether you can live with a 3 dB, 5 dB loss. Now, this picture isn't here for this reason, but seeing Marv brought it up, I'll explain something. The way this is set up, the antenna signal comes in from the antenna, comes out of the RX out into the LNA, where it splits. And after the LNA, you've probably got more signal than you need. So often you'll have to put pads in here because it'll be a little bit too strong, too much power. So, but it comes out, it splits into a T. I could have used something prettier, but this looked better on the photo than one of my good mini circuit ones. One goes to the SDR. This one goes back into the RX in and then out to the transceiver. What does this mean? It means that for those of you who start listening, you can listen on both your SDR and on your ICOM 706, in this case, your normal radio, your brick radio. So you have the dual RX. Yes, you've got the loss because in any system where you're splitting a signal, you're going to have loss. The difference being here, it's outside of the SDR switch, so you can compensate for it. The MFJ one is inside, and therefore you can't start adding things before it to compensate for the losses. This particular one, it wasn't my intention, but soon Marv made the comments on it. When this is powered up, the signal, these relays are over. So if you lose power on this, your signal goes directly from your transmitter to your antenna. It does not go through any of this receive section. So if you forget to, or your grandkids pull the power cable out of the back of here, or you dog choose a PTT line, you're not going to blow any of this receive gear. Okay. Now what?
Okay. Yeah. Okay. Paul. Yeah. Yeah. I wanted to add a couple of things. So this is the RX in, RX out switch. So I bought one of each of these from Paul. So it's got an extra port on it. You can see the RX in and RX out, because I was asking, how do we simulate the same? How do we make his switches do the same thing that the MFJ one does, by i.e. splitting so you can monitor both receivers, but do it intelligently? And so I was listening to Hassan's presentation when he was showing how he had things set up on 6 meters with the switch and the LNA and the bandpass filter and so on. And I remember him pointing out, again, we're talking about weak signal work, right? So signals coming in the antenna port here, the first thing it's going to hit is the LNA. That if you get a good quality LNA, as Hassan pointed out, with a good noise figure, okay, now you're not messing up your noise floor, increasing signal noise ratio and stuff. So with that amplifier, so that's the best place to put it. The first thing that the signal should see is a nice LNA with a great noise figure. Now that it's amplified, I can do a lot of stuff with it. I can run it through a bandpass filter. I can feed multiple receivers. I can put the attenuators in and do whatever I want and not impact the incoming signal, negatively, at least severely. So one of the next tests I'm going to be doing is, in addition to splitting it up like here, what is in the path between the SDR switch and the LNA? I've put a little programmable attenuator. And my goal is to try and find out what's the ideal signal level that these SDRs like to see. Okay. Do they like to see a lot of signal, a little signal? What's the ideal signal level that they like to see, or signal level range? And if I can then put pads in, as Paul pointed out, the output of before that SDR, I can optimize things as much as possible with my signal. So that's the next thing I'm going to be looking at and trying to figure out and take some data and see if there's a sweet spot for the incoming signal level of the SDR receivers.
Thank you. And so on here, we've got FEP, BPF, LNA, and then whatever else you guys can think of. And that's what can go in between here. Front end protection, bandpass filter, LNA. But just before I go off this picture, we'll have a which came first, the chicken or the egg. Now, which should you put in line first, the bandpass filter or the LNA. So we come out of here, it's out. Do we go straight into the LNA and amplify everything? Or do we go into a bandpass filter first and narrow down what we want and only amplify the part of the band that we're interested in? I've got a couple of comments about that further on, but I can tell you that the standard thinking that I get from most people is you go front end protection, bandpass filter, LNA. And that's why they're in that order. Why use protection? Okay, well, if you look at this, this is, for those who are interested, this was a very nice Landvar 2-meter LNA. One of the, in the 90s, these were the ones to have. Good for about 750 watts passing through them. And this one is on eBay for $75. Not quite sure if you get anything for your $75, but you can see this has taken some sort of hit. I'm going to call it static, just for the sake of of a guess to what it took. But you can see it is all burnt out here inside. Why use front end protection? To stop this sort of thing happening. Array Solutions make a very nice one. Most of you know Array Solutions, and they charge $79, $80 for their front end protection. You can see a couple of diodes in there, or pins in there, and the circuit diagram to go with it. This is one that's available on the internet, on eBay. 2 different sites. This is if you buy it from the guy that says it's made in America and it's American made and he did it. That's $25. If you buy it from the guy in China that says we make it, then it's $14. I couldn't see a difference between the two when I looked at the websites. So a couple of different options. If anything goes, these go before your SDR and your LNA blows up. Bandpass filters. One of the gentlemen that's on here, he and Lance have been discussing filters. His comment was, and when I was looking for things to talk about, his comment was that a lot of SDRs are wide open like barn doors, the receivers. And he wanted me to comment on that. So yes, they are. And there's a reason they are, because they're wideband receivers. If you take all the filters out of in front of your icon before the receiver, it's going to be exactly the same. You know, your icon has the equivalent of something like this inside it. This one, as you can see, is for HF, and it's band selectable via these little 5 volt. You add 5 volts to one of these, and it changes the band. This one, I'm making the assumption that you add a voltage to one of these to change the frequency, but I didn't get that far in looking it up. Again, this is on eBay. I think these are about $60 to $80 on eBay. They were very inexpensive. This one comes from a guy in Greece, and I know a few of the hams have had good luck with it. This is just a 6-meter one, purely for 6 meters, $34, something like that. And you can put an SMA on here, an SMA on there, and connect it in line. Well, that's just band specific for 6 meters. NTOEME do SAW filters, SAW bandpass filters, surface acoustic wave devices. I had to look that up. And I know from past experience that they are very good filters, bandpass filters. And I certainly would look at going this way. But for those who can see the bottom, the insertion loss is 2 to 3 dB on the lower bands and up to 5 dB on 2 meters. I mean, we've discussed the problems with insertion loss. So you've got a very, very good filter here. But now we go back to the question, what if you put this before your preamplifier, then you've lost 5 dB. If you put this after your preamplifier, you may find it to be very useful because you may have too much signal coming out of your preamplifier into the front end of your SDR. These are $40 a piece from NTOEME. They will put N types on if you prefer N type to BNC. Low noise amplifier, or preamplifiers as a lot of you call them. Alex, who often pops in here, K6 VHF, this is one of his amplifiers. You can see his figures on here. Now remember, one of the main reasons for putting an LNA in line is to set your noise figure. It's the first thing that your signal hits, and so it's used to set your noise figure. ARR, very popular. This is a receive only one because that's all we need. And these go for about $99, band specific, and they also have a bit of a filter inside them. I know that both Bill and Lance use these and have tapped them inside. This was a wonderful one. Go ahead.
Hey, Paul, we've tapped the RF or the remote RF version of them. The 160 watt RF handling one is the ones we've tapped. There'd be no reason to tap this one.
Thank you. Well, unfortunately now the 160 watt one is no longer available. He no longer makes it because this was a very nice one. It's basically this inside there with those relays. And I know it was those relays because I bought those relays from him when he stopped making them. So those would have gone in there if he'd have carried on making them, but I bought all of this stock off him. So Bill, not liking the fact that they didn't make this anymore, came up with the RX in and the RX out, which we've seen many uses for. But the idea is that you could just put any LNA of your choice in here and it instantly becomes 100, 160 watt LNA. So in this basic configuration here or here, you can transmit on your radio and it will not go through here. You are not going to blow this LNA up. And if you change bands, you take this one out and you put a 2 meter LNA in, or a 6 meter, or a 10 meter, or a 432. All you do is you change this rather than have to buy 3 or 4 different versions of this, which again is no longer available. WW1L, Tim. Anybody who lives on the East Coast listens with envy to Tim because he's working Europe when we're still working the same grid. He lives on the coast of Maine, and it's annoying to watch him working everybody and you can't hear anybody. So chatting to Tim, Tim has been an SDR convert longer than I have. And his view is you put things out at the tower as far as the SDR is concerned. Now, everything that we've discussed from the MFJ to the SDR switch to everything up to this point can all go at the tower. There is no reason, and I'm not going to go into configurations at the moment, but there's no reason you can't put any of that stuff at the tower, including a Dow Key 402 relay, and run a kilowatt through things. Now, the cheapest and easiest way of doing it is just with 2 of these connectors, which are $10.99 off Amazon today, and 100 foot of Cat5 cable. And I've run 150 feet of Cat5 and a pair of these adapters. And I put the SDR right out at the 2 meter antenna, plugged this into my computer, and had no problems on receive. Here's a caveat. If you start transmitting, Cat5 cable makes a great antenna. And you may start having problems with it turning off computer programs and interfering with things and stopping SDR console working, things like that. Okay. So how do we fix that? And this is This is where Tim wins. Fiber optic cable. Now, this stuff's immune to RF as far as, you know, you're not going to interfere with it. This stuff I thought was in the dreamland prices for most of us until he started pointing out what he uses. Now, keep in mind, I'm not saying that this is the right cable for this box because I didn't look that closely when I copied and pasted the pictures. They had the best picture. What you would do here, if we take this switch and we call this switch the fun cube, your SDR, and we put one of these at the tower, we put the SDR switch, the MFJ, anything else, whatever you want at the tower, and you come back to the shack on fiber optics where you've got the matching box, and then from there, you just take that straight into your computer. Instead of using these cables here, you would use these. So just replace this picture with that. I'm not smart enough to do that on Photoshop. Pair of these, and I think these were the right ones that Tim pointed out to me. $40 for the pair. 98 feet, 30 meters of fiber optic cable, $17. A little bit cheaper than coax. And so you put this up on at the tower, you bring this back to the shack, your losses on coax are zero. You've set, because you're using LNAs up here before your SDR switch, you've set your noise figure with only a tiny bit of coax and not running 150 foot of coax back to the shack. SDR console, why have I brought this picture up? Because I'm about to hit mute and Rick, K5GZR, is about to discuss something that most of us miss in SDR console. I put 2 slides on here for him. Most of us miss this in SDR console when we set it up. It's called signal history. So now he knows what he's talking about. And it's very, very useful. Over to you, Rick.
Okay, so these are, I was looking earlier, and this, you turn on signal history from, where is it? Oh, it's in the view tab in the spectrum section at the very right. There's a box where you turn on the signal history. And so what happens here is this is current time. The right-hand side is current time, and it's essentially a waterfall that moves from the right-hand side to the left. And so we'll just take the bottom one. And so what that shows is about 45 seconds of history of the signal that is for any given rate or the radio that you have associated this with. And this one here was Hassan. This was his transmit period and his receive period. So that's why there's the blank section where he has it set to mute the SDR. Oh yeah, I'm moving my cursor around and it's not doing anything. But so this is a good example to show where you have, for instance, if you're doing MSK, Meteor scatter, you can see where the Meteor, where the meteors have come through, or you can look and see tropo. Another thing that I was just talking with one of the guys at lunch today is he was wondering about the meter on his radio was kind of kicking as he was transmitting. And I said, well, I can just put we only live about 3 miles apart. So I could turn on the signal history and we could see whether it's actually transmitting a variable or a varying output, or whether it's consistent, and know whether maybe something loose in his antenna. But again, that's how you can turn it on. It's pretty cool to be able to watch. I think most of these things were done on 6 meters. When we were talking, 500, 600, 700 mile paths in the morning. Anything else you need me to mention, Paul?
No, just the difference. This one, this one shows you tropo, the way the signal's in, and it's in there all the time. If you see these where they go up quickly, then drop down, go up quickly, then drop down, these are meteorites. It's a classic meteorite signal. And bear in mind, when we say we're looking at the band, you're only looking at the 3 kilohertz that you're looking at. This is one station signal to you. This is not looking at all of 6 meters. This is just looking at the one station who's transmitting to you. So on this particular case, there was a little bit of tropo. Then we got a meteor scatter ping, another meteor scatter, another meteor scatter, another meteor scatter. And we had a little bit of tropo in here, one more meteor scatter ping, 2 more, and then done. All of that was in one transmission.
Paul, your picture that has all the receivers or multiple receivers, does it have S meters in any of them?
Yes.
Okay, so it was right there. So the S meter at the top, basically that signal history is a time recording of what the S meter is showing.
Thank you, sir. I asked him on those because they recorded them for this presentation. Okay. Now, questions. Most of the people on here know far more about SDRs than I do. And I'm sure they're going to be happy to help if I'm not around. They'll answer any questions. My shack is, from as far as I'm concerned, my radio is 3 times 55-inch monitors. They were $179 TVs from Walmart, and I don't look at the front of my radio. That is what I look at. With
So
an
Paul,
SDR, yeah, go ahead.
So do you have dongles for the video cards, or how do you drive 3 different monitors out of your computer?
I have these little adapters that go into the USB the convert from USB to HDMI.
Okay.
Maybe $10, $15 a piece on Amazon.
So you don't have to have special cards and any of that kind of stuff. Just
No, not in the slightest. Just the cheapest TVs that Walmart had on sale because they were no longer the latest model. And one of them takes HDMI straight. The other 2 take the little USB to HDMI adapters.
Yeah. Hey, Paul.
Yes, sir.
I just muted that. That was awesome, Rick, because I had not seen that, but I'm just going to share my other screen here for a second.
Let me stop sharing.
Yeah, if you don't mind, that would help here. Let me just move over to this one here. Okay, this is my receiver that I got up in Platteville remote, and so like what you were doing there with the view, that was something I had not seen before. At least I've never used it, but there it is working real time right now. If you're looking at, and I presume this is I guess this would be whichever receiver I'm on right now, which is the 260, I think. Is that right, Rick?
Yeah, right. This is the one that is, for instance, yes, it's whichever one you selected.
Yeah. Okay. So it's this one, and the beauty of this is we're trying to figure out how to measure the distance to the moon when we were doing EME, and one of the thoughts is I could use this to do a ping and receive, and it'll be recorded and it'll show exactly what the difference is in seconds. I'm wondering if I can maybe change the scale here to be down to like, 2 or 3 seconds. Is that possible?
Over on the left-hand side
Yeah,
of the
see,
signal history window,
this is options.
yeah, there's a speed with medium, and I don't think it's,
It can go very slow or it can go really fast. I guess fast would be the what I'd want, right? Probably. So if I go to fast, it's moving along. Yeah, it's from 0 to 5 seconds. So I could probably get like down to a bit. Anyway, it records the audio too, so we can measure it pretty closely, and that'll give us the exact distance from us to the moon and back.
and I'll just mention it will also record the IQ. It'll record the quadrature stuff, and you can play back any frequency you want to.
Super. I love SDR console. It's got to be the best I've ever seen. This is quite the toy. I love the technology.
Lots of knobs. I wanted to, if anybody, well, sometimes there's a question of what is the input to SDR console? What is it that it's getting? And the answer is it's digital quadrature IQ. Now, the difference between the different SDRs is how that information gets from the SDR into SDR console. And that's part of what, that's part of when you choose the specific SDR. It's the one that says, okay, well, it's coming in as an audio signal, like, or it's coming in on some of them come in on TCP/IP connection, Ethernet connection. But basically, it's a digital quadrature signal, and that's the difference between the SDRs is how it gets from the SDR into SDR console, and that's taken care of. That's why not every SDR in the whole world is supported, because Simon actually has to say, okay, this is how stuff is going to get from the SDR into SDR console. Okay.
Thank you. Bill?
Yes, Paul, I need you to go back to your presentation.
Okay, can you answer one question whilst I pull the presentation?
Well, while you're doing that, I'm going to answer the one that's up in the chat.
That's good. That's what I was going to put you on to. I'll go into the screen share.
Okay, and the shorter answer is it's grounded. There's absolutely no reason to put that onto a load, and you certainly don't want to leave it open, so I just grounded it. Okay, go back to your using fiber for right there. Okay, go back one page to this guy here. Okay, this is going to use, I'm questioning the particular products being used together here, because this thing is going to use RJ45 or the Cat 5e or 6 in a very non-traditional role. This will not be, these things have a couple of transformers in them and a little bit of other isolation things. There's not much else in these. So this is not actually 10 base T or 100 base T or 1000 base T running over the coax. It's pure, or rather the cat cable. It's purely power and the USB signal that's been conditioned a little bit to get it to run over that. And I'll go to the next one. Right in the descriptions, it's talking about 1G or 1000 base SC. So this thing is actually Ethernet protocol savvy, and I don't think those will just pop on here. So has that actually been tested with this particular device?
I've not tested it with a particular device. No, I've only used those adapters. There are some of those adapters that didn't have all the electronics in, that were just like back-to-back connectors.
Yeah, and I'm thinking that's kind of the one that you have, and I don't think this box is going to necessarily do what we're talking about. This is a great idea using fiber. Maybe we have another product here.
This is what Tim, yeah, Tim uses these.
Okay, but there's going to need to be something there than the device that you popped up, because
Yes.
that device is not going is designed to do something extremely more simplistic. Okay, can you go to the one that shows the RXO RXI in the first one you showed? Nope, go one more notch beyond that. The first one that you had. Oh, right there. Okay. First off, don't give your engineer a heart attack. Do not do what Paul showed here and come out of this into a T connector. You're looking at, you know, probably 5 to 6 dB loss doing that, and the possibility unstrung signals of a lot of reflections and stuff. That really needs to be a splitter right at that point.
Well, the splitter didn't photograph nice.
Yeah, understood. But somebody's going to point at that and look, hey, look, Paul, he knows everything, and he did that. No, don't do that. The second thing is, and I'm going to touch on a couple of things here about the RXO RXI box. You said that if you didn't have push to talk hooked up, but you had power hooked up, you could transmit and nothing would get hurt. That's not true. You'd blow the hell out of the LNA. This does require, you know, a assertive push to talk signal to switch into transmit mode. The safety situation is built in, and unfortunately I don't have a picture of the board, but on the bottom of the board is a place for a capacitor. And at 6 meters, it's about 50 puffs. And at 10 meters, at 432 megahertz, it's about 10 puffs. You put that capacitor in, and this thing becomes RF switching. And my suggestion is not using it in an RF switch mode. That was put in there in case somebody wants to make sure that if push to talk doesn't assert, it doesn't hurt anything, because it will switch quick enough to most likely protect the preamp. As a matter of fact, ARR's RF switching design might have been, RF sensing design might have been a bit plagiarized in this. There are 4 connectors across the back for anybody that was being astute. The first 3 are the same as on the regular SDR switch. Push to talk, or power in, push to talk in, push to talk out for a amplifier, and I'll talk just a bit more about that. It is purely a Schottky diode brought over to the push to talk line in. And as long as it's a modern amplifier with solid state push to talk circuit in that needs ground to transmit, it should work just fine. If you hook up a an SB220 that's been modified for 6 meters that has not had the soft key circuit put into it, I can guarantee you there will be a lot of smoke coming out of this box. So it is a very simplistic circuit. And the 4th connector is actually power for the LNA. If you want to power the LNA up and down as you're switching it in and out, void oscillations in it or whatever, there's a switched power out that is active when it's in the receive mode.
And it outputs whatever the input voltage is.
Minus about 0.2 of a volt.
Okay.
Next question. Anybody else want to correct my English? Thank you, Bill. He designed them, that's why he's sat there. Go ahead.
I have a very beginner novice question for you, or for Bill, or for Rick, or for anybody here. This this is going to sound like a stupid question, but I've never done this and I'd like to learn how to do it. If I put all of that stuff up on SDR console so I can see the whole band and all the FT8 activity while I'm operating EME, and I can see people coming in on sideband during a band opening, how do I move my transmitter to that frequency and mode that when I choose the SDR thing to look at, or when I select that, I mean, how does that get changed?
If you look at one of the other videos that we did, there's more information on there, but it's all done through OmniRig. And what you have to make sure when you set it up is that you're not asking your K3 to change the frequency and SDR console to change the frequency. You're only asking SDR console to change the frequency, and that will change the frequency on your rig. Otherwise, what happens is you'll start off with 6 individual frequencies and they'll all end up moving on to 1. But that's it. If you have a glance on the other video, it's in there how to set it up.
Okay, thanks very much.
I have one other, this has been discussed a couple of times. One other way of doing it is to have a completely separate receiver, and I say just another receiver, and have the radio, the external radio and all of that be the one that you actually, when you're transmitting and receiving, that's the one that you're going to use, and you leave the other 6 alone to just monitor their specific frequencies. So if you pick one mode or one frequency, you would operate that separate receiver and that separate set of, is that me that's making that noise?
No.
Okay. So you would have a whole separate one that you would control the frequency and the mode and so on with SDR console, and talk to the radio, and then to your your box radio for transmit.
So, and I do
just
that.
Leave this setup alone.
By receivers, he means these. He doesn't mean different SDRs. He means these. Just one of the words. It's a strange wording from Simon when he called it this. And
Well, it's the same idea as a slice in the.
yes, in flex language. And to be honest, Lance, that is the way I do it. In reality, this is a pretty way of doing it and making everything look good, and it works very well like this. But I actually do what Rick says. I just have one of these set up that my 7300 or 9700 talks to, and the rest I just leave on receive, and I'll just change the frequency on this.
Hey, Paul, can I do a little demo for you?
Absolutely. There we
So
go.
yeah, I have a question. So what's the difference or the goal there as opposed to, because what I do, if I'm going to be, as you can use, what do they call them? They're not instances of SDR console, different identities, right? So if I'm going to be operating 6 meters with those 6 receivers, that's one identity. If I'm going to be using the radio, like with the SDR and HF, I have a different identity where I change the frequencies and play stuff and whatnot. Is that something different?
Are you talking about configuration, whatever, when it comes up? It's
Yeah,
the very first window that comes up when you start SDR. Yeah.
Right. You have different identities there. So I have different ones set up. Is this the same thing or something different?
It's different.
Okay.
This would be, what we're talking about is something that brings up what Paul has. And then go ahead, Paul.
Yeah, I was going to say, like, so when I move my cursor over any of these things, you can see the little thing come up. It says select. Okay. And if you look over to the left here, where it says 50.260. Okay. So right now I'm selected on 260. So if I wanted to change my transceiver and everything over to a different frequency, I just go over here and I select this, and it switches right over to 313. You see how I did that? And just, because if you put your cursor over the window that you want, you'll see there's a select and unmute. You also have to remember to unmute, but in this case, it automatically unmutes whichever one you're listening to. Also, let me just show you. I'm going to switch over to my other monitor here. So this is what the other monitor shows, and so what I've got running here is I've got WSJT on the left. I've got JTDX on the right. I'm using different audio channels for both of those. I see K0JH is working with JR1. 6 must be open that way. Anyway, but you kind of get the idea here. It's all in the audio channels. Is what I've got here is I've got 8 audio channels, and if I go back to this one, if I look at the receiver, each one of these receivers has a different audio. See, when I went on 313, it shows line 5, right? And that line 5 is going to JTDX. If I switch over here to 260, select that, it changes it to line 3. Anyway.
Okay, and so.
And by the way, note these levels here I've got on R2, the SDR. These are because I've got a preamp in front of. I got one of those LNA in front there. I've lowered the LNA, but these are the readings that N2EME is using. So you can kind of see the way he's kind of optimized it for the R2.
So this receiver, the one that you have, the 50.260.
Yeah.
Scroll the left hand down so we can see the frequency just for the heck of it.
Sure. Hang on a second.
So we can know for sure. There we go.
Yeah.
So how is it that, or what have you configured so that that copy of WSJT-X controls the frequency of that radio? Or have you got a bunch of different
So in this case,
serial cables?
Yeah, I've got 8 serial cable, or I got 7 across here. Okay, so each one of my radios uses a different virtual audio cable.
But
if I go,
you got an audio cable, but you also have to control the frequency too. But go ahead.
Right. So controlling the frequency.
I think he wants to see the external radio, Paul. That external radio connection that's in SDR.
To talk to the external radios, I'm using Node Red to synchronize HRD. This is in my regular station. This is just a remote receiver I'm looking at. But in my regular station, I use a HRD, and I synchronize that with my amplifier, because it knows that I'm on the right frequency and everything, and it also synchronizes it with WSJT and JTDX as well as SDR console. So if I change the frequency on SDR console, everything changes. If I change it on my, if I click on WSJT to switch over to a different mode, and WSJT says, okay, that must be 313, it changes everything or 313.
For the particular radio, for the particular receiver that copy of WSJT-X is associated with through a serial cable.
Do you have, so Paul, do you have the external, you're still using OmniRig through SDR to drive everything else. There's one of the menus on the left shows that external radio connection, and maybe that's what the question is. So when you set up, one of those, if you scroll down, one of them should say external radio.
Yeah, but there's also another connection to the receivers that's not, quote, external radio.
Well, it's true. No, the external radio, when you pull up the external radio module in SDR, it pulls up OmniRig. So SDR tells OmniRig to change the transceiver and everything else. Within WSJT, you don't tell it to change the radio. Okay, it does not, WSJT is not configured to change the frequency of the radio. All the changes come through OmniRig and SDR console.
Right.
Does that make sense?
That's
Yeah,
correct.
When I get my station hooked up down in Haswell, I'll do another Zoom on it, and I can show you how I got
Yeah,
it set,
that'll be good.
so you guys can see what's going on. But that'll be for a different night.
So does WSJT-X get set up to not interface with the transmitter, but to interface with OmniRig?
In my case,
Yeah, you tell, when you set up WSJT, you tell it for rig none.
right there. Yeah, see, it says none right now. This
See,
is just
yeah, rig is none. So all it's doing, the only thing you have to set up in WSJT is the audio tab to tell it which one of the virtual audio cables to use to receive the signal, and then whatever sound card and mechanism you use to transmit. So if you go to the audio tab there, Paul, that's the one.
Yep.
All
Line
right.
three.
So you see he's got right. So you see that's probably for the sideband one, right? Because it's going out to speakers, but whatever. That tells you that's the audio cable that comes in associated with each receiver, right? And then what you want the output to go to. Usually you send the CW and the sideband to the speaker. If you've got, whatever your radio's output sound path is when you're using WSJT, you'll put there for output. But for rig, you say none. So any changes you make to WSJT is not going to change the frequency of the radio.
Yeah. Okay.
In this case, he's doing receive only, so the
Yeah, this
output is not used.
Yeah, this is just for receive only, but in the case when I'm using Ham Radio Deluxe, I select Ham Radio Deluxe as my radio, and in that way, if I try using WSJT, it tells HRD to switch over to 260, and then HRD tells everything else to switch over to 260.
Yeah, what I did is I made a desktop shortcut for each instance. It just calls WSJT-X and it'll say --rig for MSK260 or whatever, and it calls up separate instances for each one of those radios. I have a separate one that's not labeled, so when I'm not using SDR console or something, I can just use WSJT or JT-X by itself. It does have the rig in it, and it operates as if normally.
Yeah, that's a good way to do it. All right, I've got to excuse me, I got to break off here, but I'm gonna let you guys chat for a little bit longer. I'm going to stop the recording, and you guys can carry on for a while. I've got a couple of sleeping grandkids here, so I gotta quiet down now. So I'll see you guys later.
Hey,
Paul.
stop sharing. There you go. Needs to go.
I got a question on the SDR console. I see.
Yeah, I mean, you can ask him. Maybe somebody will answer.
He's being
Well, I had abandoned SDR altogether because the SDR console kept crashing, and to a point it stopped working. And I kept unloading, uninstalling it, and installing, downloading the latest version, and I could not make it work stable at all whatsoever. So I abandoned SDR, but I want to get back on it. If anybody can tell me, the fix, how can I make my Windows 10 with...
there he brings up the swear word.
okay. Well, tell us what kind of SDR.
What was happening?
It just freezes up. It starts opening up.
Okay.
And when you start it never comes to the window to select your SDR. I had two dongles that I could choose one or the other.
I have the lockup occasionally, but it is purely because the USB cable is within reach of my elbow, and I occasionally bump it enough that it disconnects slightly. And all I have to do is stop and restart the radio itself, not SDR console completely, but that you're talking a more extensive problem.
Yeah. I mean, I even sent an email to that. I forgot his name is,
Simon.
and he sent me to Simon. Yeah, I sent him the file, and really never got back any concrete answers. Windows been updated several times ever since, but I kind of gave